You know how some things in life just change at a really steady, predictable pace? Well, it turns out there's a simple but an incredibly powerful mathematical code that describes these patterns. It's in everything from your phone bill to how a plant grows. It's really a language that shapes our world. And today, we're going to learn how to speak it.
So, here's our game plan. We're going to start by seeing how math is kind of hiding in plain sight in our everyday lives. Then, we'll break down its basic grammar, unlock the amazing power of the number 1, and see how it creates these patterns all around us. And finally, we'll pull it all together with one universal formula that honestly explains just about everything.
All right, let's jump right in. And we're not going to start with a bunch of abstract equations. Nope. We're going to start with simple stuff you see every day and translate it into the language of math.
Okay, picture this. You're at the store. The red boxes have 4 pens each, and the blue ones have 5 pencils. You grab some of each, and hey, the cashier even gives you 3 extra pens for free. So how could we write a quick little recipe to figure out the total number of things you just got?
Well, we can write it just like this. 4x plus 5y plus 3. See, x is just a placeholder for how many red boxes you bought, and y is for the blue ones. With this one little expression, you can instantly find your total, no matter how many boxes you buy. It's a super powerful shorthand for a real-world situation.
Or how about another one? Say you're building a garden. You've got different costs, right? The fencing for the long sides, the fencing for the short sides, and then the seeds to fill up the whole area inside. And just like that, we can capture that entire project in one neat expression. Let's say it's $200 a meter for the length, $160 for the width, and $50 per square meter for the seeds. All of a sudden, our entire budget is right there, described in the clear, simple language of math.
Okay, so we've been throwing these expressions around, but what do all those letters and numbers actually mean? Let's take a minute and break down the grammar of this language.
First up, those letters you see, the X or the L, those are called variables. Just think of them as little buckets or placeholders for a number that can change, like how many boxes you buy or how long your garden is. Now, that number that's kind of attached to the variable, that's called the coefficient. In our pen example, 4x, the 4 is the coefficient. It's the multiplier. It tells you the rate, in this case, 4 pens per box. So each of these individual chunks, the 4x, the 5y, or even that standalone number 3, is called a term. They're the basic building blocks, kind of like words in a sentence. And when you string these terms together with plus or minus signs, you get what we call a polynomial. Now, a really key feature here is its degree, which is just the highest exponent on any of the variables. And trust me, that little detail is about to become super important. This is where it gets really interesting. We're going to zoom in on the simplest, but maybe the most powerful type of expression, one where the degree is just 1. These are called linear relationships, and you are about to see that they are, well, they're absolutely everywhere. A fantastic way to think about a linear relationship is like a simple machine. You feed a number in one side, it follows one simple rule, and it spits out a predictable number on the other side. It's a reliable, consistent process every single time. The real magic is the rule that's programmed inside the machine. In this case, the rule is take the input, multiply it by 2, and then add 3. So if you top in a 4, the machine goes, okay, 2 times 4 is 8, plus 3, that's 11. And out comes 11. Simple as that. All right, pop quiz for you. What do you think happens if we put a negative number into this machine? Let's say a -6. Does the rule still work? Yep, of course it does. The machine just follows its programming, no questions asked. It takes the -6, multiplies it by 2 to get -12, then adds 3. And the result? -9. It's this consistency that makes these relationships so incredibly useful. You know, this simple, predictable machine, it's not just some abstract math concept. It's actually the engine that drives tons of patterns of steady growth and decay that we see in the real world all the time. Just look at this pattern of tiles. At each new stage, what happens? We add exactly 2 more tiles. Stage 1 has 1, stage 2 has 3, stage 3 has 5. See, the amount of change is constant, and that whole pattern can be perfectly described by the linear formula 2n minus 1, where n is just the stage number. And this exact same logic works whether things are growing or, well, shrinking. A plant that grows a steady half-foot every single month, that's a linear pattern. A new phone that loses exactly $800 of its value every single year,
That's also a linear pattern. The key, the secret, is that the rate of change is always, always constant. So we've got all these different situations. The tiles, the plant, the phone, they all follow the same underlying logic. So the big question is there one single master formula that can describe all of them? Oh yeah, you bet there is.
And here it is, y equals ax plus b. This is it. Think of this as the master key for any linear pattern you'll ever see. The A is that constant rate of change we keep talking about, like the $800 your phone loses each year. And B, that's your starting point, the price you first paid for the phone. With just those two numbers, you can describe and predict the entire pattern.
Okay, let's put this master key to the test with a real-world puzzle. Let's say your phone bill was $350 for 10 gigabytes of data one month, and then $550 for 20 gigs the next month. There's a linear pattern here. Can we use our formula to figure out the exact pricing plan? By plugging those numbers into our formula, we can do a little detective work and solve for A and B. And what do we find? The rate A is 20, and the starting point B is 150. This reveals the phone company's secret. There's a $150 fixed monthly fee, and on top of that, it costs exactly $20 for every single gigabyte of data you use. We just decoded the bill. So now that you know the code, I promise you are going to start seeing it everywhere. The next time you see a pattern of steady, constant change, you'll know that simple, powerful formula that's driving it. So ask yourself, what patterns in your own life, your commute, your budget, your fitness goals, are just waiting to be understood with a simple, straight line?